Hey everybody, it's Mr. Carr again. Today we're going to be talking about 9.3 circles. Focus today with circles though is pretty much just the equations and how we can translate them and understand how to go back and forth between given information into like either a translated equation or finding it from the scenario. So we'll talk about a few examples of that. First thing though, let's talk about definition. Well, I guess these are the two types we'll work with here. If you are doing a circle that's at the origin, it's just going to be x squared plus y squared equals radius squared. And again, the center is at the origin, so that's 0, 0, and then r is the radius. So again, you notice that if it's r squared is in the equation, you square root that to get to the radius. The translated version looks like this. We got x minus h squared, y minus k squared, but still equals r squared. HK is my center now. So again, this is taking a circle at the origin and moving it around based on whatever translations we're doing. So where does this apply? So equations of circles. So a circle by definition is the set of all points in a plane that are equidistant from a given point on the plane called the center. Okay. You'll notice, if you kind of pay close attention, this looks a lot like our distance formula. And that's on purpose. Again, the distance from the center point, HK, to any point that's on the circle is that same distance, which is radius. Okay, that any segment with endpoints at the center and a point on the circle is that radius is the idea. Okay, so let's apply this a little bit here. So we'll start with a word problem here. The plan for a park puts the center of a circular pond of radius 0.6 miles at 2.5 miles east and 3.58 miles south of the park headquarters. Write an equation to represent the border of the pond using the headquarters as the origin. So if the headquarters is the origin, and we're going to go look at east and south. So just thinking it this way real quick, north, south, east, west. We're basically thinking of it as a coordinate grid. We got positive direction here. We got positive direction here. Got negative is west, negative is south. Okay. So if the headquarters is at 0, 0 right here, the park is going to be east and south. So it's going to be something like this over here. Okay. So that means for my H value, if it's going east, that's like the X direction. So that's going to be H equals a positive 2.5. The K value is going to go 3.8 miles south. So it's a negative 3.8. The radius is 0.6. Okay. So when I set this up, because I'm not at the origin, I'm going to use x minus h squared plus y minus k squared equals r squared. So that means we got x minus 2.5 squared plus y minus a negative 3.8. So I'm just going to make that a positive 3.8. And that equals 0.6 squared. And that is honestly fine like that. If you really want to, you can take the 0.6 and square it. Okay, so if I do that, I get 0.36. So honestly, it's either one's the same thing. It doesn't matter. 0.36 like that. Okay, either one is doable for this problem. Okay, so this is one you can check on your own. You want to write that out real quick, try it out. So just pause the video and let's go on to the next thing. So we have instead of giving a verbal description of some of that stuff, we want to write the equation of this graph right here. Again, what we need is center, radius. That's all we need. So here's my center is at 0, 3. The radius is pretty straightforward because I can just count it out. If this is going to 7, it goes 1, 2, 3, 4, 5, 6, 7. So R equals 7 in this case. Okay, so that means I can go x minus 0 squared plus y minus 3 squared equals 7 squared. Totally acceptable there as well. If I write x minus 0, I don't have to do it that way. I could just leave it as x squared, but I still want to leave it as y minus 3 squared equals 7 squared or 49. Okay, either one of those is same idea. And again, try it out for yourself real quick. We move on to the next one. Okay, write an equation given a diameter. The thing to remember about diameter is that it is double the radius. So we want to write the equation of a circle if the endpoints of the diameter are at 2, 8 and 2, negative 2. It might help to graph it out a little bit just to kind of give an idea for this. I'm not going to do that in this case just because I want to go through and kind of talk about the algebra idea of it. thinking about the diameter and thinking about where our center of the circle is. The diameter is goes through the center of a circle. So by definition, diameter has to pass through, whoops, don't want that. It would pass through this, like this right here. So I kind of just model it real quick. I've got, let's say 2, -2, and 2, 8. That's kind of what's happening. It's not be more tilted, but it's get the idea. So when we look at this, in fact, actually, I think about it, might as well just do it this way. So it's not going to look like, okay, it's not going to look like that. It's actually going to look like this. It's going to be a vertical diameter like that. Then, so get rid of this real quick. This will be 2, -2, and this will be 2, 8. So I'm just kind of doing this as, rough sketch. The idea is I want my midpoint. Okay, that's why we covered midpoint before. So the midpoint of my diameter is going to be the center of the circle. All right, so let me do that real quick. So midpoint of diameter is the center. Okay, so if I do that, I can do, it'll be 2 + 2 divided by 2, 8 plus a -2 divided by 2. So my center is going to be at 4 divided by 2 is 2. 8 plus a -2 is a +6 divided by 2 is 3. So that's what this point is here is 2, 3. The last thing I need is the radius. Now, potentially I could do the distance formula. Thankfully, this is just a vertical line. So I can actually figure out the radius by just kind of counting it out. If I go from 3 to 8, that is 1, 2, 3, 4, 5 spaces away. Same thing if I went the other direction. If I subtracted 5, I get down to -2. So my radius is just 5. Now, worst case scenario, if it was not on a vertical line, it was like more slanted, distance formula. If you have the center and you have a point that's on the edge of the circle or one of the endpoints, you can just do distance formula between an endpoint and your center point. Okay, I'm just not going to do it here because it's just a lot of extra work for 5. So my formula, x minus h, so it'll be x minus 2 squared plus y minus 3 squared equals 5 squared. And again, you can write it as 5 squared or 25. Either one's good. Okay, try this one on your own if you want. Well, let's move on. Okay, so now we're going to do our graphing of this. So we're just working backwards from this. We just want to look at x squared plus y squared equals 16, identify the center, and then identify the radius. Based on the fact that that's x squared plus y squared, we know the center is at the origin 0, 0. My radius is actually going to be r squared equals 16. Okay, remember that's in the equation. So if I square root both sides, my radius is just a length of 4. So from my centerpiece, I can go 1, 2, 3, 4 here, 1, 2, 3, 4 here, 1, 2, 3, 4 here, and 1, 2, 3, 4 here. Doesn't have to be perfect, okay? Especially if, I didn't draw my scale very well, so I don't want to do it that way. Bottom line is, for my graph, I'm looking for the center, and I'm looking for like 4 points that go around that center with that correct radius. Okay, that's what the key on these types of problems. Here, we got an extra challenge. Graph an equation that's not in standard form. So you notice the way this is set up. X squared plus y squared plus 2x minus 8y does not look like any other problems we've done. So we are actually going to go a nice old skill, completing the square. This is what's going to help us determine the center and the radius. So it's going to have a lot going on. So first thing I want to do is I'm going to rearrange. So we're going to have x squared plus 2x. I'm going to do plus blank for a second, plus y squared minus 8y plus another blank. And then instead of plus 4, I'm going to go ahead and subtract that to both sides. So that equals a -4. With a circle, remember it's x minus h squared. If I do completing the square, I can turn both of those, I can factor both sections of x and y into something that looks like that. So in the first case, if I take 2 divided by 1, that's 2. 2 squared is 4. So I'm going to put a 4 here. For this one, I've got -8 to start with. So -8 divided by 2 is a -4. -4 squared is a +16. So I'll put a 16 here. Okay. So I've added 4 to in that X section and 16 to the Y section. But with completing the square in my equations like this, I have to also balance it out. If I add 4 and 16 to the left side, I've got to add it to the right side as well. So now, completing the square, I can now do my factoring. X squared plus 2x plus 4, it follows the pattern of x plus 2 squared. Again, that's this value right here is the same as that value. This value right here, the -4, is what this will factor into. So that'll be plus y minus 4 squared. And then I got -4 plus 4 plus 16 just gives me 16. Okay, so that's how I can use completing the square. I'm doing it twice, one for the x's and one for the y's. Now I can identify my center. It is the opposite of this, so -2, and the opposite of that is +4. My radius squared is 16, so that means I square root it to get to 4 for my radius. Okay, and now graphing is just plotting the center, so -2, and then 1, 2, 3, 4. And then from that center point, I'm going to go 4 in 4 different directions. So I can go 1, 2, 3, 4 over here, 1, 2, 3, 4 down, 1, 2, 3, 4 to the left, and 1, 2, 3, 4 up. Doesn't look like a nice circle because my graph is not quite to scale, but make it close enough. All right, again, center, have the correct center, have the correct radius in the 4 directions. All right. So again, this is another one that you can do completing the square. Pause it, try it on your own. But that is it for today, actually. Okay. So again, lots of stuff with circles. We're really trying to understand how to find the center, how to find the radius, given a variety of ways of looking at our equations. Okay, as long as you can understand the graphing of it, you'll be fine for this part. All right, that's it for today. Take care, everybody.